And welcome to today's meteorology segment. We'll be talking climate for a quick moment as well. First thing we're looking at here are pressure cells on windy.com. They've got a great mobile app, by the way. Maybe check that out if you like. Windy.com. And we're looking at pressure here, massively low pressure here around the South Polar region. The entire South Geographic Pole area dominated by low pressure. Anyway, we'll advance this map into tomorrow. There's where we expect things to be according to the European forecast on Sunday, August 8th at 12 noon Eastern Daylight Time. And if you're wondering where we're located right here in Lehigh Valley, Pennsylvania. If you've got custom weather forecasts you'd like us to do, let us know in the comments. We'll consider doing it. We take requests. Now, we are streaming live to Twitch right now. If you haven't seen the mobile app and so on, check out the smartphone app, twitch.tv. It's fantastic. It'll let you know when we go live. And we're looking to increase our Twitch viewership a little bit. Can you help us get to 100 viewers by becoming a follower over on Twitch? Again, I'm pretty sure you're able to visit a website. Twitch.tv/smAsho is where this video was originally premiered. And let's take a look at lightning here on the NASA GOES Lightning Mapper. So we've got some lightning here, especially south of the Great Lakes here, moving across northern Indiana into Ohio as we make the video. Also in Minnesota, some in Kansas, Nebraska, South Dakota, and a little bit around the Carolinas as far as U.S. lightning. Here's a real-time lightning map. Actually, before we do that, let's talk about Lake Agassiz. No, not Lake Agassiz. Geologists have long known of an ancient lake, glacial Lake Agassiz, that occupied as many as 1.5 million square kilometers of what is now southern Manitoba and central Saskatchewan, up to the Alberta border. The lake formed as the 3-kilometer thick Laurentide ice shield atop the northern half of North America began to melt around 16,000 years ago, creating a dam that prevented would-be meltwaters from making their way to the Hudson Bay. So this is one of the many things that was going on around the Younger Dryas, just before the Younger Dryas, in this case at 16,000 years ago. A lake the size of the equivalent of the Great Lakes drained in a very short period of time. And it's not understood why. So there's some folks studying it. And I'm just going to let the article scroll here. If you'd like to have a read, feel free to pause the video. We'll be here when you get back. That's the glory of video on demand. Said Paul Carling, what I find deeply satisfying is that modern hydraulic modeling, when applied to the evidence preserved in the landscape, shows how a phenomenal flood propagated 12,000 years ago, said Paul Carling. When all the uncertainties are considered, the outcome remains pretty solid. So while temperatures were returning to normal, we saw some sudden and major fluctuations in Earth's climate. We don't know for sure that the flood caused Earth to slip back into the Ice Age, but certainly if you put that much water into the Arctic Ocean, models show you get cooling of the Northern Hemisphere climate. It disrupts the North Atlantic oscillating flow, and it's got nothing to do with Andre Agassiz, Lake Agassiz. That was a phys.org article in the Earth section, by the way. Some good science there showing up from phys.org. So here's your real-time lightning map. Quite a bit of lightning here around in the Western Middle East, you'd call that. We've got some terrestrial lightning in the U.S. just south of Minneapolis. Hey, Minneapolis, there's thunder rolling in. Yowzers. Some active lightning cells there. I use lightningmaps.org when I hear thunder. It gives you a good idea of if it's right over your head or where it's located. Lightningmaps.org. Highly recommended. Not a lot of weather warnings here, although we've got some foggy conditions around the Rocky Mountains and some flood watches here around the Carolina and Virginia coasts. What are those tan areas? Those are fire weather, special weather statement, and marine weather statements. That's weather.gov, by the way, if you want to look at that yourself. Next, looking at the jet stream here. Here's the eastern world. And just bear with me a minute. I want to check the life of the stream. It looks just fine. So there are the jet streams of the eastern world, still blowing backward over the western Pacific and the Indian Ocean a little bit here, although it looks like it's returning to more coherent state. Here are the surface winds. Again, some strong winds around the Southern Ocean here. Some strong winds off the coast of Japan as well, rotating the Earth to the western portion. Here are the surface winds of the west, pretty uneventful there. Here are the 250 hectopascal winds known as the jet stream. And check out the extreme meridional jet stream flow once again. It looks like a dictionary definition of extreme meridional jet stream flow, where the jet stream flows south and north instead of west to east. A little bit more coherent jet streams in the southern hemisphere once again, as it is winter down there. Once again, everybody, welcome to the Neo-Renaissance. Visit our homepage, smAsho.com. Lots of changes coming there soon. We've made some changes to the forum as well, thanks to all of our new registered users and so on. Lots of stuff happening. You can even play our smAshomash.org presents the Sun videos 1 through 9, although there are like 17 of them now. You can find our playlist, youtube.com/smAshomash. Thanks to everybody who supports our efforts. Next, we're going to look at cosmic rays real quick as part of our meteorology segment. Cosmic rays they do matter, as apparently cosmic rays have the capacity to make the planet cloudy for extended periods of time. Here are the cosmic rays from Agassiz and Barentsburg neutron monitors. Down over the past 30 days at Agassiz, and down over the past 30 days at Barentsburg. Next, we'll go to Athens, Greece. So we're going very much farther south here. Those were some Russian cosmic ray monitors. How about a Grecian cosmic ray monitor? And we've got some erroneous data there. Truncating this data, we still see a mild downward trend here over the past, I'll say, 21 days. Next, we'll go even farther south to Mexico City, see what's going on at that cosmic ray monitor. Or not. Just bear with me, folks. Again, we are streaming live. Let's see if we can get Mexico City here. It doesn't look like it's going to load. We'll also look at Oulu, Finland. There's Oulu. Slight downward trend in the past 30 at Oulu. How about DOMC Antarctica? Slight downward trend there. DOMB Antarctica. Slight downward trend there. As you would expect, as the solar cycle ramps up, cosmic ray flux ramps down. We won't talk about the correlation or the causation, as this is a meteorology segment. Here you can see these strong storms here moving around Minneapolis. They are moving east-northeast, it looks like. And let's take a look at some more data here from the cloud layer. There's the cloud layer. And here's the water vapor map, which should give you the most comprehensive information. Some sudden cloud nucleation happening up there. You can see some moisture being added to the map. And you can see it on the 3.9 nanometer radiation map as well. So here's your meteorology recap. There's the U.S. Doppler radar map. Here's the cloud layer. And again, if you've got custom weather you'd like us to forecast, let us know in the comments. We'll consider doing another video later today. But there is the water vapor. Thanks for tuning in. Remember to press like and subscribe if you enjoy the content. Tell your friends and foes about the channel. The algorithms don't seem to be helping us very much. And I've been your host, Dan, a.k.a. smAshomash, signing off from the Smash News Network, least busted. Name it news.